NASA DART spacecraft crashes into asteroid and saves humanity. NASA has launched a space mission called the Double Asteroid Redirection Test, DART, NEOS, to test a strategy for protecting Earth from potentially catastrophic asteroids. In November of 2021, it was sent into orbit from the planet below. With this mission, scientists hope to determine whether or not an impact from a spacecraft could one day be used to divert an asteroid on a collision course with Earth by transferring its momentum to the asteroid. This will be done by crashing a space probe into the minor planet moon Dimorphous of the double asteroid Didymos. Is this method even practicable? And if not, what will happen to Earth in case of an asteroid threat? Stay tuned as we continue this voyage of NASA's DART spacecraft colliding with an asteroid to save humanity. Let's begin with an overview of the topic. NASA's Double Asteroid Rendezvous Test, DART spacecraft collided with a tiny asteroid around 7 million miles, 11 million kilometers from Earth tonight, September 26th, in what the US Space Agency called the first such planetary defense test. The goal is to change Dimorphous's orbit around its parent asteroid Didymos, enough to show that a potentially hazardous asteroid can be diverted from a collision course with Earth. Elena Adams, DART's mission systems engineer at the Johns Hopkins University Applied Physics Laboratory, JHUAPL, remarked that as far as we can tell, our first planetary defense test was a success. Following the successful crash, people on Earth, in my opinion, need more rest. Without a doubt, I will. That's something our dinosaur ancestors couldn't do 65 million years ago when the Chicxulub asteroid smashed into the Yucatan Peninsula, wiping them out for good. Before the tragedy, Catherine Culvin, NASA's top scientist and senior climate advisor, observed, "The dinosaurs didn't have a space program to save them, but we do." As a result, DART represents a tremendous advancement in our ability to anticipate future threats and take steps to safeguard the Earth. Next, drive the DART spacecraft towards Dimorphous. The DART spacecraft, approximately the size of a golf cart, collided with Dimorphous at 11:14 UTC, traveling at about 14,000 miles per hour. 22,500 kilometers per hour. Even though the spacecraft weighed only 1,320 pounds, 600 kilograms, NASA expected it to be enough to accelerate Dimorphous's orbit around its parent planet. "The spacecraft is quite little," remarked DART coordinator lead at JHUAPL and planetary scientist Nancy Chabot before the collision. NASA's JHUAPL oversees the initiative. "It's like driving a golf cart right into the Great Pyramid." The Mission Control Center at JHUAPL for DART was a mix of serenity and suspense as the spacecraft sped towards its destruction, even though it was on schedule. Engineers would have had to perform any 21 backup plans in the case of a collision, but happily nothing went wrong. DART's navigation system locked onto Dimorphous in the spacecraft's penultimate hour of approach, allowing the spacecraft's process to be automated for the last 4 hours. DART's primary camera transmitted a picture to Earth once every second until the spacecraft was impacted by the asteroid, at which point the stream went dark. "It's nerve-wracking," said Andy Cheng, JHUAPL's top scientist for planetary defense, in the days leading up to the crash. In 2011, he had the idea of the DART mission. On November 23, 2021, we launched the DART mission, which cost $313 million. Dimorphous transformed from a mysterious sparkling dot to a detailed scene of stones, crags, and dreary terrain shortly after DART's arrival. The DART Mission Operations Center's live stream went dark at the exact moment, and the flight controllers inside the center jumped for joy and high-fived each other. "Asteroids are a target for DART's targeting mechanism," Adams noted. "I think we were all holding our breath," she said, comparing the emotions to horror and excitement simultaneously. "I'm honestly surprised that none of us passed out." Moving on, spaceship destruction in the name of planetary defense. The DART mission is the first test of NASA's planetary defense concept of a kinetic impactor, in which a spacecraft purposefully collides with an asteroid to adjust its orbit. This is a simple approach to defend Earth if a potentially deadly asteroid is found 5 or 10 years before a likely impact. Human action is changing the orbits of a naturally occurring celestial body. Such a precedent does not exist in human history, according to Tom Statler, a scientist with NASA's DART program. "This is the stuff of a science fiction literature and incredibly cheesy episodes of Star Trek. I recall thinking as a kid, and now it's true." According to NASA's researchers, an asteroid impacting Earth and wreaking widespread catastrophe is a remote but realistic possibility. About 40% of Earth-threatening asteroids with diameters of up to 500 feet or 140 meters, have already been detected, and NASA is still searching the skies for more. NASA is developing a new space telescope Sentinel called the Near-Earth Object Surveyor, with the sole mission of identifying potentially deadly asteroids. It's feasible that this mission will launch in 2026. However, if a killer asteroid is identified, humanity must be prepared to deflect it. As a result, DART. According to a story published this morning by Space.com, NASA's Associate Administrator for Science, Thomas Zubachen, stated, "We're incredibly delighted every time our space missions defend life on Earth. NASA chose Dimorphous as a small moon orbiting Didymos as the target of the DART collision for various reasons. The moonlet is a part of a binary system and orbits its parent every 11 hours and 55 minutes. This time is short enough that any change in its orbit should be observable by ground-based telescopes in future investigations." Following the binary asteroid system, Didymos and Dimorphous, a binary asteroid system, were discovered in 1996 and 2003 respectively, and have since been the focus of intense research. Using a binary asteroid system rather than a single asteroid allowed NASA to measure the asteroid's deflection with a single spacecraft and the assistance of ground-based observatories rather than a second, more expensive spacecraft, as Cheng had previously advised. Despite NASA's designation of Didymos and Dimorphous as potentially dangerous asteroids, neither object is projected to threaten Earth shortly, decades to centuries. DART was anticipated to accelerate Dimorphous's orbit around Didymos by around 10 minutes. Therefore, there was little risk of the binary system's orbit being changed to pass dangerously near Earth, and at only 7 million kilometers distant, Didymos and Dimorphous are closer to Earth than they will be for the next 40 years. A signal sent from the DART to Earth only takes 38 seconds to complete the round trip. As a result, it's the right asteroid at the right time, Chabot noted. Dimorphous is also a favorite among astronomers because of its size, squarely in the range of the asteroids about which NASA is most concerned due to potential Earth impacts. A NASA S-type asteroid is a rocky kind and one of the most prevalent in our solar system. Moving on, here is a description of the asteroid. "We think anything like DART would be big enough to divert a Dimorphous-sized asteroid," planetary scientist Mallory DeCosta, a modeler with DART's impact working group at JHUAPL, told reporters in the hours before impact. However, because DART is the first trip of its kind, scientists had no idea what might be discovered on Dimorphous. Is the asteroid a jumble of sand and pebbles or solid massive rock? By the way, what was its precise shape? The success of an asteroid deflection mission using a DART-type system depends on factors like these. In its final moments, the DART spacecraft captured some incredible images of Didymos and Dimorphous. Nobody had ever seen the tiny moon before. Scientists used DART to determine that it was an alien world in the shape of an egg, with a surface of boulders and a rocky, uneven topography. Carolyn Ernst, a scientist at JHUAPL and the creator of the DART project's Draco camera device, exclaimed, "It truly looks magnificent. It's truly adorable. It's the tiny moon in the sky. It's just too cute." According to Angela Stickle, chief of the DART Impact Working Group at JHUAPL, spacecraft impact simulations and models indicate a crater up to 65 feet. 20 meters wide. Stickle stated of the DART spacecraft, "We expect it to fragment severely upon impact with its target. Some DART remnants may remain on Dimorphous." According to NASA, even touching Dimorphous was a technological marvel, with the DART spacecraft returning images at a rate of 1 per second. Many people witnessed the spacecraft crash and burn. DART launched a small CubeSat named Lycia Cube in the weeks following the impact to observe the aftermath of the asteroid's collision with Earth. Close-up images of the effect and the ejector it ejected from Dimorphous should be visible in the photographs taken by CubeSat, which are expected to reach Earth in the days following the impact. Finally, was the first test of planetary defense a success for humanity? From different locations in the solar system, the new James Webb Telescope, the Hubble Space Telescope, and the Lucy spacecraft on their asteroid mission all monitored the impact as it occurred. The event has been tracked by a global network of ground-based telescopes which will continue to monitor the binary Didymos-Dimorphous system over time to determine how much the speed of Dimorphous's orbit has increased. Statler remarked, "Our needs are for 73 seconds, but we think we're going to change by about 10 minutes. Determining whether or not the DART impact was successful as a test of planetary defense will take some time. Over the next 6 months, the Didymos-Dimorphous asteroid system will be monitored by over 3 dozen telescopes worldwide, with at least one on each continent." According to Christina Thomas, a planetary scientist at Northern Arizona University who leads the DART observations working group, the first radar measurements of the impact could arrive as early as Tuesday, September 27th. "We shall observe Didymos until it is no longer observable. Thomas stated. DART scientists aim to estimate how much DART displaced Dimorphous within the next 2 months. Volunteer students and university organizations from all over the world have joined the observation campaign to contribute their observations to the DART project. When referring to the groups working on ground-based telescopes, Thomas stated that there are a lot of them. It's exciting not to be able to keep track of stuff. The European Space Agency has declared that it will deploy its spacecraft to the Didymos Dimorphous asteroid system to evaluate the DART mission's results. Here is a future expedition that will examine the space rocks and DART's crater on Dimorphous. It is scheduled to launch in 2024, arrive at the asteroid and enter orbit around the binary asteroid system by 2027. The technology of hitting the asteroid is a challenge, Chabot told reporters a few hours before impact. However, much more happens after that. Our video for today has now ended. I'm glad you enjoyed yourself. Don't forget to comment, subscribe, and like the video. We appreciate you taking the time to watch.